Good morning, everyone, and welcome to our third Homegrown Research webinar for 2024. Today we'll be discussing cereal research updates. My name is Megan Rosso, and I'm the Crops Extension Specialist with Saskatchewan Agriculture in Moose Jaw, and I'll be chairing today's event. CEUs are being offered for certified crop advisors on this webinar. To get credit, you need to attend the entire event live, and there will be a QR code at the end of the presentation to collect credit. If you missed the code and have attended live, please email us afterwards and we can work with you to get your credit. Before we start with the formal presentation, we will begin with an introduction to the Homegrown Research Series. Why are we calling this the Homegrown Research Series? This is because all the research presented today is from the research sites involved in the Agri-ARM network across Saskatchewan. It is all local research that will be directly applied on your farm. So what is Agri-ARM? Agri-ARM is a network of producer-directed applied research and demonstration organizations located across Saskatchewan. All operating individually, each site strives to collaborate on a broad range of projects, generating results relevant to growers over a wide area. Agri-ARM sites receive funding through the Saskatchewan Ministry of Agriculture, as well as project-based funding from governments, commodity groups, and private industry. So what do Agri-ARM sites do and why does it benefit Saskatchewan producers? Agri-ARM is a one-stop for research, demonstration, and extension activities across Saskatchewan. They provide reliable results across a wide range of soil and climatic conditions. The data generated is relevant to local farms and provides comprehensive support for the adoption, development, and validation of new technologies and practices. We encourage you to visit the Agri-ARM website shown on the URL shown on the screen. Here you can find more information about the organization, upcoming events, current projects, fact sheets, or research updates. The website also contains contacts and more information for each of the Agri-ARM sites, as well as you can follow them on social media. Agri-ARM also focuses on local producer needs and is always looking for new ideas. You can submit your ideas by reaching out to the site nearest to you or by using the submission form on their website as shown here in red. We encourage you to visit the website for your local Agri-ARM site where you'll notice research updates, contact information, and ways to follow them on social media. As well, the Agri-ARM sites often host field days or winter meetings to share results. Here you'll notice dates for each of the site's upcoming summer field days. You can contact your local Agri-ARM site for more details. In the next few slides, I'm going to highlight each of the sites we have representatives from today. Joining us today will be Christiane Catelier from the Indian Head Research Foundation, where she is a research associate. IHARF was established in 1990 when a group of local area producers gathered with researchers from the Indian Head Research Farm to discuss areas of cooperation within the agricultural research field. Since then, IHARF has grown to become a nonprofit organization funded by a combination of government, producer, and industry sources. Also speaking today will be Mike Hall, Research Coordinator from the East Central Research Foundation located in Yorkton, Saskatchewan. The ECRF was established in 1996 and is a nonprofit organization whose mandate is to conduct crop production research and extension activities for the agricultural industry of East Central Saskatchewan. It is directed by a board of local producers and advised by provincial specialists. Brianne McInnes, Operations Manager for the Northeast Agriculture Research Foundation, located in Melfort, will also be joining us today. NARF was established in 1997 to coordinate and support crop production research activities in northeastern Saskatchewan. It is a non-for-profit organization that consists of a farmer board with several advisors from the provincial and federal governments, as well as from agribusiness. It is also affiliated with the AAFC Research Farm, also located in Melfort. Our final speaker today is Alex Waldner from the Western Applied Research Corporation located in Scott. WARC is a nonprofit organization that is governed by a board of directors consisting of Northwest Saskatchewan producers. They work in partnership with AAFC at the Scott Research Farm. WARC's mandate includes transferring technology from research and evaluating the economic implications of technology for Saskatchewan producers. I also wanted to briefly mention that the 2024 Crop Diagnostic School will be held in person on July 24th and July 25th in Melfort in partnership with NARF. Keep watching our social media pages for registration details in the coming months. Along with this information, we have additional resources for everyone under our handout sections in the chat box area of the toolbar. Resources will be shared along with the recording after the webinar is complete. Today, we'll have a 15-minute presentation from each speaker, followed by a question panel with all the speakers. The entire session will be recorded, so if you miss anything or wish to revisit any of the presentations, you will be able to. Recording links will be sent out in the next few days in a follow-up email. An evaluation will also pop up at the end of the webinar this morning. Please fill out the evaluation, as these help us determine what topics you want to learn more about and help prioritize research needs for the future. We have a few housekeeping notes to keep in mind during the webinar. If anybody has any questions during any of the presentations, you may type them in the question box in the bottom right-hand side of your control panel. Your question will remain anonymous and will only be sent to me. During the presentation, you will be muted so that we can ensure there is no feedback that will interfere with the audio. With that, we will get started. So we're going to start the day off with a presentation from Christiane Catelier, who has been a research associate with our IHARF since 2012.
Good morning.
Morning.
So my screen is being shared. You can see my presentation?
Yep.
Okay, I don't see it for some reason. Okay, so I'll be talking to you about the on-farm field scale research that we basically rolled out in 2023. So it was the first big year having lots of sites with the on-farm field scale research program at IHARF. And this was in partnership with crop commissions in Saskatchewan. So when we say on farm, we mean like in farmers' fields, in crops under commercial production. Okay, so how it works at this stage is that the commissions choose the research topics and the target number of sites of each protocol. The goal is to get a few sites of each protocol spread out throughout the province. IHARF and also WARC this coming year act as research support for the programs, and then trial managers work directly with farmers to complete the trials as per the protocols. So when the sites are nearby, we, as an IHARF WARC, hopefully more sites going forward, act as the trial managers. But if the sites are remote, then the trial managers are usually the farmers agronomists or sometimes the commission extension staff. So the goal for us going forward is to maintain this partnership with the commissions, but also as Agri-ARM starts to develop some independence with our own programs within the Agri-ARM sites, so that we can start to expand the number and types of protocols that are being completed. So this was the list of topics or protocols that were offered this season. Since all of the commissions were also basically in their pilot year of their programs as well, they all just chose a single protocol to support this year to keep it simple. Pulse growers also had a few different protocols being offered, other field scale trials that we weren't involved in directly. And then going forward, there's going to be more different protocols being offered for each crop, especially after seeing how much interest there was in this first year. So I'll go over the list of protocols for 2024 at the end here, but first I'll briefly go over the results from the 2023 trials. So for wheat and canola, the topic was foliar applied nitrogen fixing biological products. And then we had a lentil seeding rate, barley seeding rate with SPG and Sask barley. So first of all, the wheat and canola, this protocol was designed to assess the effectiveness of the foliar applied N fixing biological on wheat or canola. Farmers chose which crop they're interested in. They didn't do both. Sometimes they did, but they didn't need to. Biological products in general are high interest at the moment, and fixing in particular. A single product was chosen for this trial though, and that was Envita. There were two options to choose from for this trial. So option A, it was basically treated versus untreated. For option B, the farmers could do the comparison on two different applied nitrogen rates. One would be their normal rate, and then a reduced rate to see if that N fixation provided by the product could make up the difference. In most cases, that reduced rate was only 10% less, but in other cases, it was more. And at a couple sites, they actually assessed a third, even lower applied nitrogen rate. So I just want to make a note here that requirement of participating in these field scale trials is replication of the treatments within the field. So that means you're doing multiple strips or passes of each of these treatments. So option A was replicated 4 times. So that's a total of 8 passes or strips. And then we're getting yield weighed on each of those strips. And then option B was replicated a minimum of 4 times or 3 times, most cases. So that was 12 treatment strips or more if they added that extra nitrogen rate. There were 12 trial sites for wheat and 9 for canola. The goal of lots of replicate sites across the province is to assess the product or practice under lots of different soil and weather conditions. We also had a range of seeding dates, May 2nd to 29th for wheat and May 13th to 30th for canola. Application timing for Envita is the 3 to 6 leaf for canola and cereal. So we were in this application window at all the sites. Some were earlier in the window, some were later. So we had lots of variability in conditions. It was good. Application dates ranged from the June 13th to 30th for wheat and June 11th to 26th for canola. The product can be tank mixed. At some location, it was applied at herbicide with the herbicide, and at some locations, it was applied as a separate pass, so we had some variability there as well. We also saw some variability in weather across the sites, though in general, most sites had warmer than normal temperatures in June, drier than normal in July. In this case, in this protocol, weather is important for crop growth, but also for efficacy of the product. So Envita is a living organism and it needs favorable conditions to be able to colonize the plants and work properly. So for results, I'll be focusing on the combined results across the sites, but you should be able to find individual site reports online on the Commission's websites. And just again, as a side note, farmers who participate in these programs get first access to all the results at a meeting in late fall or early winter every year at this point. And that's, I think, the goal going forward as well. So we'll start with the wheat. In this table, you see the bushel per acre yield of untreated versus Envita treated for each applied N rate at each site. So for example, at Wynyard, you'll see there is a normal, a reduced, and a low N rate. They'd had 3 different N rates at that site. So they're shown separately in the table. For the sake of discussion, I did show the difference in yield between the treatments for each site and N rate. And then you can see that the table started from the largest positive to the largest negative difference. But more importantly, and what's most important here is that none of these differences were statistically significant at the P less than 0.05 level. I also put the standard error in the table, which is our estimate of variability or how accurate that this treatment average is. And you can see that the yield difference is less than the standard error most of the time in a lot of these cases. So this indicates that that difference isn't even really measurable. So now we have a graph. In the graph, you can see the yield of the untreated. Untreated is in yellow, X is in the yellow line. And then the treated is in blue against N supply across all the sites combined. So the points, the X's and O's, are the site averages. So these are the same values you see in the table here. I just put them there for a visual. And then residual soil nitrate was added to the applied nitrogen rate to estimate the total N supply at each site and nitrogen rate. And then from there, the line shows the result of the combined analysis. So we see that overall yields increase significantly with nitrogen supply. So that's our p-value of 0.017, less than 0.05. But there's no significant difference in yield for treated versus untreated. This is the Envita factor, greater than 0.05, and then regardless of N supply. So it didn't go, the difference didn't increase with a higher N supply or increase with lower N supply. So that's the interaction is less than 0.05. I do want to highlight the results at Wynyard. We saw in that table, this top value here, that we had a large yield difference with Envita at that normal N rate. It was 7.9 bushel difference, but it's important to note here that the interaction wasn't significant at this site. P is 0.162 for the interaction. So that means that we can't look at this N rate individually. But the test for Envita overall at this site, this is average across all the N rates, was nearly significant, 0.057, and so worth noting. So with the post hoc pairwise comparison, the difference was significant at 0.05, and it was a 4 bushel per acre higher yield with Envita application when average across all the N rates. But again, this is one site out of 12 that we did the trial. I'd also like to show the protein results here because we can measure it a little more precisely than yield on a field scale. Protein data was analyzed the same as yield, so as a function of N supply. Overall, protein increased significantly with N supply again. But again, we didn't see a significant response to Envita application regardless of N supply. At individual sites, there was a significant effect of Envita application at Kipling. Protein was significantly lower when Envita was applied, and that the difference was 0.3%. For canola, the results are shown the same as they were for the wheat sites. So with the table here, and again, most importantly, at all the sites and applied N rates, treated and untreated yields were not significantly different at the 95% confidence level when analyzed individually. And again, I wanted to show the average yield differences only for the sake of discussion. And again, we see that the difference between the treated and untreated is usually lower than the standard error. And then for the combined analysis for canola, we see that yield didn't change with N supply. We don't have a significant p-value for N supply here. Means that yield wasn't likely limited by N supply across all the sites. And again, there was no significant difference in yield with Envita application regardless of N supply. Not showing it here, but there was also no significant difference in canola protein or oil content with Envita application regardless of N supply across all sites or at individual sites. So in the end, we weren't able to measure much of an effect of Envita on wheat or canola. Some things to consider that might have affected the efficacy of the product. Storage and handling. So it's like this product is similar to like a soil inoculant or a seed inoculant. Yeah, should be kept cool. It should be kept cool until application time, so that sometimes isn't always the case. It needs to stay sealed until it's mixed, and then it needs to be applied right after it's mixed. It should be applied last to the tank mix, and you need to avoid hot products in the mix, like fertilizers like MS, UAN. You should be applying it earlier in the day when the stomata are open. This is the point of entry into the plant. Cool and moist conditions at application are ideal because you avoid any drying out before colonization can occur. You need adequate water volume, so at least 10 gallons per acre. In general, we followed most of this at all the sites. Don't know exactly what the conditions were that the things were stored under, but in general, for application, we followed these things almost to a T. It's also important weather conditions, like things that are in our control, weather conditions in the days following the application. So you want that cool, moist conditions so that you have high moisture conditions, your stomata stay open, the product stays hydrated, so you get more colonization. So those are just factors that might have affected the results, but in general, we were pretty close to those conditions. Maybe not the conditions after application timing, but the way the products are described, they provide N to the plant when it's not fulfilling its N requirements, so the amount able to be taken up by the plant doesn't fulfill its requirements, so it would more likely be effective in when N supply is limited for some reason. And we saw that canola in particular was not limited by N across the trial sites at this season, so that might have been a factor as well. There's been some other research published recently that I don't need to go into detail here, but our results are basically consistent with these results. So now moving on to lentil seeding rate. So a lentil seeding rate trial might seem very simple, not like something we kind of have figured out already, uninteresting. Some might think they've been growing lentils for a long time and they have this figured out, but this protocol was chosen as an extension to small plot research results that showed that higher seeding rates than what's recommended and commonly used were sometimes beneficial to lentil yields, but it might depend on the growing conditions and mainly moisture. Lentils are usually seeded at a flat rate of 60 pounds per acre for small reds, 90 pounds per acre for large greens. Usually brings you pretty close to that recommended target stand of 12 plants per square foot. Depending on your seed size, you could be a little higher or lower than this. So the objective of the protocol was to assess whether that higher seeding rate than this are beneficial and under which conditions. And then to add to that growth conditions part of the question, there was an additional layer added at sites with hummocky landscapes where the response to seeding rate was assessed at different landscape positions. So the reasoning behind being that hilltops are drier, depressions are wetter. But I won't be presenting those results today. For simplicity, you can look those up, I think on the SPG website. For treatments, all sites compared 3 different seeding rates, except for one site only had 2 seeding rates. They weren't necessarily exactly these target plant densities, but we had, you know, a range of different seeding rates. The goal was to have them targeting approximately the 12, 18, and 24 plants per square foot, but we left that a little bit flexible. Depending on what the farmer was interested in or comfortable with. So sometimes they're a little bit lower or sometimes even a little higher. There were 17 sites for this trial and distributed throughout the lentil growing area. Little higher concentration in the northwest. So for this year, we're looking for a little better representation in the southwest there. So right to the results, you'll see on the x-axis down here, we have seeding density as the seeding rate measurement. This is the viable seeds per square foot, the viable seeds that are put in the ground, planted before emergence. So this seeding rate measurement basically doesn't factor in the emergence rate or seedling mortality, because that we know will differ from site to site based on conditions and management. So we want to be able to compare sites equally. We see here, so you see you're like close to a little bit higher than 12, a little bit higher than 18, a little bit higher than 24, where most of the sites had those seeding rates. seeding densities. So you'll see that plant density did increase with seeding density. When this combined across all sites, this is exactly what we would expect, of course. The results are consistent across sites. 12 of the 14 sites had that same expected increase in plant density with an increased seeding rate. 2 sites had no significant difference in plant density between treatments. These sites had poor variable emergence, so that's how we can explain that. Seedling mortality. So this is the proportion of viable seeds that didn't make it out of the ground or didn't survive past that seedling stage. So even though we had the differences in plant density that we wanted, as we saw in the previous slide, there was still a significant increase in mortality with higher seeding rates. So we didn't get all the plants seeded at the higher seeding rates. There was fewer than expected, is what that means. The results were again fairly consistent at the individual sites. 8 of the 14 sites had a similar increase in seedling mortality at higher seeding rates, and this has been shown before. This isn't new information. Also, as expected, 2 more sites were marginally significant increase in in mortality with seeding rates. And then at 4 of 14 sites, there was no significant change in mortality as the seeding rate increased. So seeding rate was the same across, or mortality was the same across the seeding rates. Emergence might have been low overall at those sites. So how did this affect the yield? Those plant populations affect yield in the end. Overall, when the sites were combined, there was a significant decrease in yield with higher seeding rates. So this isn't what was expected. If you remember, the research was showing potential with higher seeding rates, but this wasn't consistent at individual sites either. 2 of the 17 sites had that similar negative yield response to seeding rate. In contrast, 2 sites had a significant positive yield response to increased seeding rate, but it was also, the yield response was also more difficult to detect. There was 13 of 17 had non-significant response to seeding rate. So yield didn't differ between seeding rates. So apart from the formally measured variables, there was also lots of visual differences noted between the different treatments in the field, however. Most were as would be expected. Emergence was more even, canopy closure was earlier and more even with higher seeding rates. There was more weed pressure at lower seeding rates. Plants were larger, healthier at the lower seeding rates. And there was earlier senescence with the higher seeding rates, but that's not certain if it was just from a maturity thing or maybe also disease pressure. At this stage, we also haven't characterized the sites in regards to differences in moisture or yield potential, but that is an objective of this protocol, and it will be interesting to see if the response to seeding rate differs with the type of environment or landscape position, as I mentioned earlier. So that's to come. Got my time here. I think I'm over time. So I won't keep going. I'm just gonna breeze through this because I'm out of time. These are just the protocols that we're offering this year. You can check these out on the commission's websites, and also you can contact myself or Kayla Slind at WARC. I'll just breeze through these really quick so you can see them, and then I'll wrap it up.
Thanks, Christiane, for all the great information. We really appreciate the time you took to join us here today. Just as a reminder, if you have any questions, please enter them into the chat box in the bottom of your control panel. We'll hold on to them for the question panel with all the speakers at the end of the presentations. Thanks again. Next up, we'll have Mike Call, who has been the research coordinator for the ECRF since 2013. And we'll start whenever you're ready, Mike.
Okay. Yeah, I'm one of the research coordinators for the Yorkton Research Farm, and it's a cooperative effort between Suncrest College and the East Central Research Foundation. And Suncrest College is a new amalgamation between Parkland College and Cumberland College. So those two colleges no longer exist. We're all Suncrest College now. So today I'm going to talk to you about our enhanced barley variety trials that we conducted in 2023. There were 7 Agri-ARM sites that participated in this study, and they're all listed here. The trial was a split plot design, so we had our main plot factors being barley management. And barley management was 4 different levels of increasing fertility from a standard to an enhanced level, which was basically another 30 pounds of nitrogen per acre. We also looked at the effect of plant growth regulator, and we looked at the effect of fungicide. And these effects were all looked at on 6 different varieties of barley. And the first 3 varieties listed here, Synergy, Connect, and Fraser, are all malt barley varieties. And the last 3, Austenson, Claymore, and Oriana, are feed varieties. So I'm going to do this backwards. I'm going to tell you what my conclusions are for each one of these sections in terms of fungicide, PGR, and enhanced nitrogen, and then show you the data that made me come to these conclusions. So the first thing to note is that conditions were pretty dry across Saskatchewan, and disease levels were quite low as a result. So for the most part, fungicide did not affect yield or grain protein. There were some exceptions. At Yorkton, there was a grain protein for Synergy was decreased by fungicide, which was implying that the yield may have been increased for Synergy, but that wasn't supported by the yield data. More interestingly, the levels of leaf disease, although they were very low, we did have some sites where fungicide reduced the leaf disease. And these were at Indian Head, Outlook, Scott, and Yorkton. But there were interactions at these sites. And what we found was that Oriana had the highest level of leaf disease when it was untreated. And fungicide made the biggest reduction in leaf disease for Oriana compared to the other varieties. Claymore also at one site had a trend to have its leaf disease levels lowered by fungicide as well, and was statistically significant if you're using LSD, but not if you're using the Tukey's test. But despite the fact that Oriana had these higher levels of leaf disease, they were still pretty low levels of leaf disease. So there's no evidence still in our study to suggest that the yield of Oriana was increased by fungicide. So let's look at the data. So here we have fungicide in blue and no fungicide in yellow for the various sites. And you can see that fungicide didn't significantly increase yield at any of the locations. And fungicide in blue here did not significantly affect grain protein at any of the locations. But like I said before, there was an interaction at Yorkton, and for some reason, Synergy sort of stood out and the grain protein was increased or was decreased by fungicide for Synergy. And while the others did not come out significant, there was definitely a trend for decreasing protein levels for Fraser, Austenson, and Claymore. So the effect of fungicide versus no fungicide on leaf disease. So you can see by my scale on the left here, the levels of leaf disease are pretty low here. But despite those low levels, we're still able to find significant reductions in leaf disease at Indian Head, Outlook, and Yorkton. And there was a trend at Scott for this. But there's interactions, like I said before. So if we look at each one of these sites individually, here we're looking at Indian Head, and you can see on the right, we have Oriana in green, and it has by far the highest level of leaf disease, which was significantly reduced as we move to the left where we applied fungicide. So this happened at Indian Head. It also happened at Yorkton. It happened at Scott, and it happened at ICDC, at Outlook. You can also see here that the blue, which is Claymore, is also being reduced, although in this case it's being reduced as a trend. But if you use the LSD to separate them, that difference actually comes out being significant. So there's definitely Oriana definitely has higher leaf disease and did benefit in terms of visual symptoms by applying fungicide. Let's go to the plant growth regulator application conclusions. So again, conditions are dry across Saskatchewan and lodging levels were extremely low at all locations. So for most sites, plant growth regulator did not affect lodging, yield, or protein. There were some exceptions. PGR increased yield at Swift Current, which was a little odd because it had very low yield potential. But the reason it had low yield potential was that it suffered a hail event. So I thought, well, maybe it helped out with lodging or something after the hail event. But according to the ratings, lodging levels were extremely low at that site still, despite the hail. So the reason for the benefit of the PGR there is open to some speculation. There are some other exceptions where PGR decreased the grain protein at Outlook despite no detectable yield increase. And PGR reduced crop height at 3 of the 6 sites, but there were interactions. And what we found was the height usually of the malt barley varieties were being reduced significantly, and the feed barley varieties were not being reduced in height significantly. And this occurred at Indian Head and Yorkton. And if you use LSD to separate means, it also occurred at Melfort. So it's possible that the plant growth regulator may be less beneficial to the feed varieties that were grown in this study, since they were unresponsive in terms of reducing their height to plant growth regulator. And these varieties also have better lodging resistance ratings. So for example, Ossison's rated as good, but Claymore and Oriana are very good. The malt varieties, Synergy is fair, Connect is good, and Fraser is good. So here's that effect of plant growth regulator here in gray on yield at the various sites. And you can see at Swift Current, you can see how low its yields are relative to the other sites due to its hail event. But that plant growth regulator did make a significant difference there. And actually, it's an economic difference too. It's five bushels, which would cover for the cost of the plant growth regulator. But still a bit of a surprising result for me. PGR only significantly reduced yield for Synergy at Indian Head, but there is also a trend for all of the varieties except Claymore. Applying PGR in gray decreased protein at Outlook and had no effect at the other sites. And PGR in gray significantly reduced crop height at all locations except Outlook, Melfort, and Scott, but there were interactions. And these are the ones that I was talking about earlier. Here we have IHARF, and PGR is significantly reducing our malt varieties in terms of height. We've got PGR on the right and no PGR on the left, but it wasn't doing it for the feed varieties. Same thing at Yorkton. Here's our malt barley varieties. They are being reduced by PGR on the right, but the feed varieties are not being reduced by PGR. And then again at NARF, if we use Tukey's, then nothing was statistically being reduced. But if you use LSD, we got reductions in the malt barley varieties, but not the feed varieties. So I'll move on to conclusions for enhancing the nitrogen application. So again, that's just increasing the nitrogen rate by 30 pounds per acre over what our base rates were. So enhancing nitrogen did not affect yield at most locations, as conditions were dry. Exception was enhancing nitrogen did increase the yield of Connect and Claymore at Indian Head. Enhancing nitrogen increased grain protein at all the locations, with effects being significant at Indian Head, Melfort, and Outlook. Grain protein was also increased at Yorkton, but only significantly for synergy. So here we go. We're looking at the main effects here, and enhancing nitrogen in red did not affect the yield at any location, but like we said, there was an interaction detected at Indian Head, where we have enhancing nitrogen increasing the yield of Connect and Claymore, but while there was a trend for many of the other varieties, it wasn't statistically significant. But Fraser doesn't seem to be getting increased by enhancing nitrogen. Overall, the enhancing nitrogen increased protein, but despite there being no site by management interaction, if you look at the sites individually, enhancing nitrogen increased grain proteins at all the locations, with effects being significant at Indian Head, Melfort, and Outlook, with an interaction at Yorkton. And at Yorkton, we saw synergy was increasing significantly with added nitrogen. And while there was a trend for a lot of the other varieties, they weren't statistically significant. So the bottom line, economically, is conditions were very dry. Well, they were dry, excepting ICDC, and actually Swift Current too. Swift Current got 95% of their rainfall, average rainfall for them, but they also suffered some of that in the form of hail, so that wasn't doing them any favors. But for the other locations, conditions were relatively dry, leaf disease levels were low, lodging was low, and yield potentials were mostly average. Fungicide did not affect yield for the most part and would not have provided an economic benefit, not even for Oriana, which had higher levels of leaf disease that were significantly reduced by fungicide. Now, even though they had higher levels of leaf disease, the level of leaf disease was still pretty low. And plant growth regulator did reduce plant height, although feed varieties seem to be less affected, and for the most part. Plant growth regulator wouldn't have proved economical because there was no yield loss occurring from lodging. Plant growth regulator reduced the yield of some varieties at Indian Head, which would be not unexpected. You don't really need to be putting a plant growth regulator down when conditions are dry. Plants don't really need to be shorter when conditions are dry. And yield was surprisingly increased by plant growth regulator at Swift Current, which had the hail event. Enhancing nitrogen would not have proven economic for the most part, as yields were unresponsive due to dry conditions. There were some exceptions at Indian Head, where the yield of some varieties were responsive to nitrogen. So overall, there's not a lot of evidence from this study to suggest varieties should be managed differently, probably mostly because of the dry conditions. You could say that Oriana is more likely to benefit from fungicide. So if we had, wetter conditions out there, we might have seen a yield improvement more likely with Oriana compared to some of the other varieties. Another speculation would be that the feed varieties might just would benefit less from the application of plant growth regulator because their heights were less responsive to plant growth regulator, and also they have higher ratings to lodging resistance. So this work was supported by Sask Barley and the Sustainable Canadian Agricultural Partnership.
Thank you, Mike, for that great presentation and the time you took to join us today. As a reminder, if you have any questions, please enter them into the chat box on the bottom of your control panel, and we'll answer them during the question panel. The next speaker we have is Brianne McInnes, who has been with NARF for 6 seasons, starting out first as a research assistant and for the last 4 years as the operations manager. We can start whenever you're ready, Brianne.
Okay, sounds good. You guys can all see my slides now?
Yep, we can see them.
Okay, sounds good. All right. Thank you for that introduction. So, like she said, my name's Brianne McInnes. I'm the operations manager for the Northeast Agriculture Research Foundation, based just 1 mile south of Melfort. We're located at the Melfort Research Farm. We've been out there for as long as I can remember. We are located at the Agriculture and Agri-Foods Canada site. So we rent office and land from them, but we are our own independent organization running our own small plot research program. We've been in operation since 1997. We're a non-for-profit organization and we operate under a board of directors consisting of producers from the Northeast area. So today I'm going to be talking to you about some of our research we've been doing this season in plant growth regulators. Since Mike already touched on PGRs and barley, I'm going to kind of skip over that project and go straight into a project we did focusing on PGRs and wheat this past season. So just a little bit of a refresher on plant growth regulators. So here I've got some visuals from a project we did about a decade ago at Melfort and Indian Head in Unity Wheat, looking at applications of manipulator at different timings. So at the top there, I've got a no PGR versus manipulator at early stem elongation on the bottom there. So a significant reduction in lodging about a decade ago when we started doing some of this work. So overall, how do they work? They act on plant growth hormones responsible for stem elongation, which essentially reduces stem internode length, thereby reducing crop height, which has the ability to reduce crop lodging for various benefits like ease of harvest and protection of yield and quality. So the two products I'm going to be focusing on today are Modus and Manipulator. So Modus has been around for a few seasons now. It's available by the company Syngenta. It has a different active ingredient than Manipulator, trinexapac ethyl, but it works by a similar mechanism, and it performs best when applied at early stem elongation of BBCH 30 to 32, and application rates for wheat and oats are 340 mils per acre, and in barley and winter wheat are 420 mils per acre. And then the second product is Manipulator, which is available by Belsheim. The active ingredient is chlormaquat chloride, and application rates in wheat are 700 mils per acre, and barley and oats is 930 mils per acre. So this is a slide I just stole from a presentation that we did on PGRs from our work in the early 2010s, showing the different active ingredients, chlormaquat chloride and trinexapac ethyl. So as you can see, this is the pathway for gibberellin biosynthesis, which is the plant growth hormone that both of these active ingredients are acting on. So they're both acting within the pathway, but just working at different steps in the pathway to alter gibberellin biosynthesis. Okay, so as far as the specific project I'm talking about today, we had funding through the ADOPT program, which is funded through the Sustainable Canadian Agricultural Partnership. And then we also had two sites funded through Sask Wheat. So far, we've only done this project in one season in 2023. We are looking to do it again for the 2024 season as well. We had 6 different sites of Outlook, Melfort, Scott, Yorkton, Indian Head, and Prince Albert. So a wide variety of different sites throughout the province, looking at crop height, lodging, maturity, grain yield, and then grain quality of test weight, seed weights, and then protein as well. So this is a little bit of a busy slide. We've got our treatment list on the right here. So we had 12 treatments. All treatments were arranged in a split plot design. The split was no PGR, manipulator, and Modus, both applied in single applications at early stem elongation at the recommended application rates for wheat. And then we've got 4 different varieties, Brandon, Elida, Redberry, Starbuck, all with different height characteristics and different resistance to lodging. And then as far as environmental conditions go across the sites, all I really want to highlight is it was obviously very hot at all of our sites, with pretty reduced precipitation across the board at all sites. And then at Outlook, the site was actually under irrigation. So although it looks like they had really reduced precipitation, they received quite a bit in the form of irrigation. So their total precipitation was actually closer to 340 mils. Now getting into the results. So just for plant density, all I wanted to highlight was that even though we were hot and dry, establishment was pretty good across all sites, well above 200 plants per meter squared, when most of our targets were 250 plants per meter squared, so pretty good establishment. As far as varieties go, there was significant difference in plant density, with Elida having significantly lower plant density at 4 sites, Redberry having the greatest plant density overall, and then Brandon was significantly lower at ICDC as well, which kind of brought down the average of that variety. Okay, so as far as height responses go, so on the left, I just have a visual here at Melfort where we've got no PGR in the bottom, and then we've got an application of Modus at the top. So you can detect a little bit of a visual difference there. So height was significantly reduced by a PGR application at 4 of the 6 sites by an average of 4 to 8 centimeters. So you can see the average difference here in that top table there. And then variety was significant at all sites, where Elida and Redberry were the taller varieties, and then Brandon and Starbuck were the shorter varieties, which is pretty on par with what their varietal characteristics are. Now, we did have a PGR by variety interaction for height, but only at 2 sites. So when we look at the first variety of Brandon, we have no response to Modus at Wark, but a significant response to Manipulator. And then we see a very similar result at iHarp as well. Moving on to Elida, we have a significant response to Modus, but not Manipulator at Wark. And then a significant response to both products at iHarp. Redberry was significantly reduced in height with both products at Wark and as well at iHarp. And then lastly, we've got Starbuck, which is a shorter variety, responding to Modus, but not Manipulator, and then not responding to either product at iHarp. And then as far as maturity goes, there was only a difference in maturity where maturity was prolonged with Manipulator by 1 day at iHarp. But overall days to maturity was pretty low at less than 100 days at all sites. Variety did significantly affect maturity, where Starbuck had the longest days to maturity, followed by Elida, and then AAC, Redberry, and Brandon having the least days to maturity. Unfortunately, lodging was really low in 2023, even though all of us sites over-applied nitrogen, rates of 110 to 182 pounds per acre of applied N was used across the site. So we were definitely over-applying N, but just due to limiting moisture, we unfortunately didn't see much lodging. We did have some lodging documented at Yorkton and iHarp, with significant reductions with both products. But again, overall degree of lodging was really low at less than 1 in the control. And then when we look at the significant variety by PGR interaction at iHarp, Redberry was the only variety where lodging was actually significantly reduced with both products. As far as grain yield, at 1 site at Melfort, we actually did see a significant reduction in grain yield with an application of Modus as compared to the control. Numerically, yield was reduced with Manipulator, but it was not significantly different from the control. At NARF, Yorkton, Wark, and CLC, we all had pretty low average grain yields, around 50 to 60 bushels per acre, but that's pretty good considering the conditions we had. iHarp has a pretty decent yield of about 80 bushels per acre, and then we're getting some pretty high yields under irrigation at Outlook at 109 bushels per acre. And then as far as variety differences in grain yield, Brandon was the highest yielding, Starbuck coming in second, and then Elida and Redberry were the lowest yielding varieties. As far as test weight, we did see a significant reduction at both iHarf and NARF with an application of manipulator as compared to no PGR, but no significant reduction with Modus. Even though we did see a significant reduction in test weights, NARF and iHarf were the sites with the highest test weight overall. So even with the reduction, we are still seeing greater test weights in comparison to the other locations. There was no effect of PGR on 1,000 seed weights, but again, at those two sites where we saw reductions in test weights, we also saw reductions in protein. So at Melfort, we saw a reduction with Modus, and then an even further reduction with manipulator. Whereas at iHarf, we just saw a significant reduction with manipulator. So protein was greatest this year at CLC. They had some really high protein, around 16%. Some decent protein happening at Yorkton and Scott, and then a little bit of lower protein at NARF, Outlook, and iHarf. And then as far as varieties go, Redberry and Elida are having higher protein, and then Branton and Starbuck have lower protein in comparison. So just some general conclusions from this project. So as far as PGRs go, when there were no product differences, both products reduced height and crop lodging. As far as varieties go, Brandon and Starbuck were the shorter varieties with different lodging resistance, higher yields, and with lower protein. And Elida and Redberry were taller with very good and fair lodging resistance, and they were lower yielding with high protein. So essentially varieties are just performing as we would have expected based on their varietal characteristics. And then when there were product differences, Modus reduced yield and protein, but only at one site, and manipulator prolonged maturity at one site and reduced test weight and protein at 2 of the sites. Now, I just did want to point out about a decade ago, we did some work in PGRs in wheat, just with manipulator at the time, but we had much more favorable conditions. We had more rain in June and July those years than we had all season this year. So we had much better conditions for applying PGRs, and we did see significant reductions with lodging at both of those locations, and then also increased yields as well with applications of manipulators. So unfortunately, when we're doing this work in 2023, we're not having as great of conditions for applying a PGR. So I just wanted to highlight some of this past work that shows some more promising responses to PGRs. And then with that, we've also done some oat PGR work at NARF and iHarf, so I just wanted to include the link to that. Unfortunately, due to time constraints, I just wasn't able to touch on that project. With that, thank you to all our funders. We have a website, neag.ca, where we post all of our trial results, and then my contact information is provided there as well if anyone needs to contact me for any reason. So yeah, with that, I am all done.
Thanks, Brianne. That was great, and we appreciate the time you took to join us today. Again, as a reminder, if you have any questions, please put them in the chat box. Lastly, we'll have Alex Waldner, who has worked as a research technician with WARC and moved into a research associate role in January with WARC. We'll start whenever you're ready, Alex.
Okay, good morning, everyone. Thank you for the introduction, Megan. Like she said, I worked with WARC a couple of years ago as their research technician. Then I went back to the U of S for my master's, which I'm still working on, but I started working with WARC again in January as a research associate. And I'm very happy to be back working with WARC and with all of the Agri-ARM sites. So today I'm going to be looking at, oops. Oh, I lost my screen here. Looking at evaluating seeding rates of wheat under various environmental conditions. So this trial was conducted in 2022 and 2023. But to start, I'd like to give acknowledgement to all of the Agri-ARM sites that were included in this study, as well as the funding that was received in 2022 from Blaine and Adam Davey Farms, Holman Farming Group, and Kuhn Farm. And we received funding in 2023 from Sask Wheat. So our current seeding rate recommendation for wheat is 20 to 25 plants per square foot. But for this study, we wanted to understand whether or not the seeding rate to optimize yield would change based on different environmental conditions, particularly during drought conditions versus adequate moisture conditions. The objective for the study was to evaluate the ideal seeding rate for wheat under various environmental conditions. We used 7 different seeding rate treatments. We included the current recommendation of 20 to 25 plants per square foot. And then we went as low as 10 plants per square foot and as high as 40 plants per square foot. In order to capture various environmental conditions, we included multiple sites and years in this study. In 2022, we started with 2 sites at Scott and at Swift Current. And then in 2023, we expanded to include 6 sites at Scott, Swift Current, Indian Head, Yorkton, Melfort, and Prince Albert. Unfortunately, we did exclude the Swift Current 2023 data from our combined analysis because they received a hailstorm in July that significantly reduced their yields. So in total, we had 7 site years of data for this study. So with our combined analysis, we found consistent trends across all site years for our yield influencing factors. So when we looked at tiller density, which was the number of tillers per plant, head size, the number of seeds per head, and head length, we found that these tended to decrease as seeding rates increase at all of our sites. And then for head density, the heads per square foot, we found that this tended to increase with increasing seeding rates. But the main message I wanted to give with this slide was that the response of these factors to seeding rate didn't change across our site years. So this tells us that these factors will consistently respond to seeding rates in this way, regardless of environmental conditions. But this was not the case for yield. So the yield response to seeding rate varied depending on the location and the year. So you can see on the graph here, each line is a different site year. And for some of our sites, the yield tended to increase with increasing seeding rates. But for other sites, we saw a decrease with increasing seeding rates. So we're seeing a different response depending on the environmental conditions at each site and each year. So in order to get a better understanding of the yield response to seeding rates in different environmental conditions, we decided to group our sites by moisture conditions. So this table here shows the growing season precipitation for each site year. And on the far side, on the right side of the screen, we show the percent of long-term average. So this tells us how the growing season precipitation compared to each site's respective long-term average. So we split these sites into a low moisture group, which included sites with below 70% of their long-term average. So this included Scott in 2022, Indian Head in 2023, Scott in 23, and Melfort in 23. The Scott 2022 did have above 70% of their long-term average, but we included this site in this group because the majority of their precipitation occurred in 2 rain events at non-ideal timings. And the temperatures in July were above average. So despite them being above 70%, they actually experienced very drought-like conditions in that year. And then we had our high moisture group, which included sites with above 70% of their long-term average. This included Swift Current in 2022, Prince Albert in 2023. It would have included Swift Current in 23 had we included that data, and then Yorkton in 23. So when we looked at the yield response to seeding rate in our different moisture groups, we found the trends were much more consistent. So in our low moisture group, the yields tended to decrease as seeding rates increased, although this was not significant. And then for our high moisture group, we saw that yields tended to increase with increasing seeding rates, and this was significant. So this tells us that yield responds differently to seeding rates under different environmental conditions. Then when we dug a little deeper into the analysis, we tried to figure out what the ideal seeding rate might be under these different moisture conditions. So first we looked at correlations between our yield influencing factors and yield, and we found that head density and tiller density were significantly correlated to yield. This meaning that they had a strong influence on yields in low moisture conditions. But the head size and the head length, which I didn't show on this slide, were not significantly correlated to yield, meaning that they did not have an influence on yield in those low moisture conditions. So when we looked at the histogram borders here, this shows us where the frequency of data points lies. And we found that our highest yields, which were 80 to 85 bushels per acre in low moisture conditions, most commonly occurred at head densities between 52 and 57 heads per square foot. And then our highest yields also most commonly occurred at tiller densities of 1.5 to 2 and 2.5 to 3.5 tillers per plant. So now that we know the head and tiller densities are strongly influencing yield in low moisture conditions, we can look at which seeding rates result in those ideal head and tiller densities. So for head density, that 52 to 57 heads per square foot occurred most commonly at seeding rates between 15 to 40 seeds per square foot. But our tiller density between 1.5 to 3.5 most commonly occurred at seeding rates of 15 to 20 seeds per square foot. And since these factors are highly correlated to yield, we found that the highest yields most frequently occurred at seeding rates between 15 to 25 seeds per square foot, resulting in yields of 80 to 85 bushels per acre. So with this, we came up with a seeding rate recommendation of 20 seeds per square foot to optimize yields in low moisture conditions. Looking at these same factors in our high moisture group, we see again that head density and tiller density are highly correlated to yield, and that the highest yields occurred most frequently at head densities between 47 and 50 heads per square foot, resulting in 90 to 100 bushels per acre yields. And our highest yields occurred with tiller densities of 1 to 2.5 and 3 to 4 tillers per plant. We also found that unlike the low moisture conditions, the head size was significantly correlated to yield, meaning that when moisture isn't limited, the number of seeds per head does have an influence on yield. And the highest yields occurred most commonly with head sizes between 27 and 30 seeds per head. So again, when we look at these factors and which had the influence on yield, which was head density and tiller density, the head densities that most commonly achieved high yields occurred at seeding rates between 30 to 35 seeds per square foot. And tiller densities that were highly correlated to yield occurred at seeding rates between 25 to 30 seeds per square foot. And our yield in the high moisture group tended to increase as seeding rates increased. So the highest yields occurred at seeding rates between 35 to 40 seeds per square foot. So as a result, we came up with a seeding rate recommendation of 30 seeds per square foot to optimize yields in high moisture conditions. Seeding rates higher than this might also increase yields, but we need to also factor in the economics when we're looking at seeding rates and whether or not that increase in seeding rate is covering the cost of that added seed. So overall, with this study, we learned that the seeding rates to optimize yields do vary based on moisture conditions, where the ideal seeding rate in low moisture conditions was at 20 seeds per square foot to maximize yield, and the ideal seeding rate in high moisture conditions was 30 seeds per square foot. Our recommendations mostly fit in with the current seeding rate recommendation, where on the lower end of the spectrum, we're optimizing yields in low moisture conditions, and then on the higher end and even pushing up to 30 seeds per square foot, we're optimizing yields in adequate moisture conditions. Of course, none of us know what the growing season will hold for precipitation, but when this data starts to become really valuable is when we look at variable rate seeding applications, whereas our hilltops might correspond to these low moisture conditions, and then our low spots would correspond to high moisture conditions. So thank you all for listening today, and thank you again to the funders for this project and all of the collaborating Agri-ARM sites.
Thanks, Alex, for all of your great information and the time you took out of your day to join us. At this time, we'll have all of our presenters turn on their webcams and we'll begin our question panel on fertilizer or on cereal update. The first question that we have is for Christiane. Will the on-farm Envita trial be done again in the future?
Actually, yes, we're doing the same trial again this year on wheat and canola. A few changes to the protocol this year. It's a choice of product, so the farmer can choose what product they want to use as long as it's a foliar applied nitrogen fixing biological. And we took out the nitrogen rate option for the protocol, but yes, we're doing the same protocol on wheat and canola this year.
Perfect. I have one here for you, Mike, on the leaf disease trial with barley on at the Outlook site. Was the location under irrigation or was it dry land?
Yeah, it'd be irrigated. All our stuff from Outlook is usually irrigated. Yep.
Perfect. Brianne, I have one for you. Will these trials be done again since the PGR trial was done on such a dry year?
Yes, we are supposed to be doing it in 2024, so we should have another year of data by next year.
Perfect. Another one here for you, Christiane. Was protein measured in the wheat trials for Envita?
Yes. Yes, I showed the protein results in the presentation. So protein increased with nitrogen rate, but was not affected by application of Envita.
Perfect. And that's back in the recording for anybody to go back and watch once we get it posted as well. Alex, how did they go to plants per square foot from the seeds per square foot?
Okay, so that was the seeding rate calculation. So for all of our seeding rate calculations, we targeted those treatments that I brought up in the beginning, ranging from 10 plants per square foot to 40. But then, of course, depending on the site and the wheat that was used, that actual seeding rate, so the actual seeds per square foot or pounds per acre, however you want to talk about it, did vary by site. But all the sites targeted those 7 different plants per square foot targets.
Okay, and another one for you, Alex. In your seeding rate trials, what row spacing did you use and what kind of metering system?
So the row spacing depended on each site because each site is working with a different drill. So I don't know the specifics for each site. I know at Scott we have a 10-inch row spacing drill with a 1-inch knife. And as for the metering system, I'm not sure how to describe that, but it's metered out according to each site's drill.
Okay, well, sounds good. Thanks for the answer. Christiane, what kind of feedback have you been receiving from producers with the results from increasing seeding rate?
I'm assuming for the lentil seeding rate study. Yes, sorry.
Yeah, I'm thinking that's what this one is applying to. Yeah.
Okay. So I'm not sure if you're thinking about producers participating or just in general. Producers participating, I think they're kind of thinking this is what they expected. And in terms of the general population, general farmers, I'm not quite sure. I haven't spoken to too many people about these results. But yeah, that's been the thought. They feel like they're where they're supposed to be.
For sure. Sounds good. Thanks for the response. Mike, what are your thoughts on what caused the lower protein with fungicide application?
Well, usually if fungicide application is increasing yield, it's going to lower protein. So anything that increases yield for wheat that isn't related to adding nitrogen is going to decrease protein. Like when we have had excess, like for example, with a plant growth regulator in 2015 when it was wetter, we put plant growth regulator down at the time and we had tremendous yield increase from it because our crop was going down early. We went from, I think, 45 to 55 bushels from using manipulator at the time. But we also lost, I think, a percentage point in protein in the process as well. So anything that increases yield that's not related to increasing nitrogen usually going to decrease your protein.
Sounds good. Another one here for you, Alex. Does the research just reflects seeds per square foot? How do you factor in survivability? Sorry, this is quite a few questions altogether. Did you do plants per square foot survivability counts as well?
Yes, so we did look at the plants per square foot or the plant density in this study. I didn't include it in the presentation, but it is included in the report. And we did find that at all sites, the plant density tended to increase with increasing seeding rates. I hope that answers the question.
Yeah, I think that did. Brianne, do you have an idea on why there may have been a reduction in protein with the PGR in wheat?
Yeah, when I think about significant sites, not necessarily, because we weren't seeing a positive yield response, like how Mike said, if you see an increase in yield, you see a reduction in protein. And that wasn't the case with adding the PGR this year. So I'm not exactly sure what would have been causing that reduction in protein, but.
Okay, sounds good. Thanks for the response. Mike, what is the procedure and stage that is used to measure height when doing a PGR trial?
Well, it's definitely well after heading, and usually six samples per plot taken from front to back within the plot, basically. And you have somebody going through with the yardstick, just calling out numbers and someone recording them. And so it goes fairly quickly.
Sounds good. Last question we had here is for Alex. You have recommendations for seeds per square foot. What does that correlate to plants per square foot that showed up after those seeding rates? And then did you use 1,000 kernel weights?
Yeah, so sorry, that seeding rate recommendation, I maybe used the wrong units, but it would be plants per square foot that you're targeting. So in the low moisture conditions, 20, and in the high moisture conditions, 30. For the seeding rate calculations, each site did factor in the germination and 1,000 kernel weight based on their seed lot that they were using. Each site was using a different variety. So those seeding rate calculations factored in the germ and 1,000 kernel weight as well as the target plant density, so the plants per square foot.
Perfect. Sorry, we had one quickly pop up here. With increasing or decreasing wheat seeding rates, would you adjust your fertilizer levels too, or leave fertilizer rates as is? This may be a question for anyone who wants to jump in on the panel and answer this one.
I know that for this project, fertilizer was based on soil test recommendations at each site, so it did vary based on the site. I'm not sure if you would want to vary those fertilizer recommendations based on seeding rates. And if anyone else has any ideas on that, they can jump in.
Sounds good. Yeah, at this time, I'd just like to thank everybody, presenters as well as attendees, for taking the time to join us for the event today. And at this point, we'll stop recording now.